Hello everyone, I'm Segabinazzi and I'm a PhD student at the University of Florence, where I'm part of the Lapidus Materials Laboratory of the Department of Earth Sciences. In this presentation, I'm going to share with you a research project that we carried out, named Architectural Heritage Monitoring, Implementing Data-Driven Preservation for Stone Corbels with low-code app tools and reporting. In this work, I'm going to present a tool that we built to address the need of a monitoring platform for mitigating the risk of detachments from historical buildings in the historic center of Florence. When discussing of deterioration of heritage materials, we usually think of them from a conservation point of view only. While this may be true for many fields of cultural heritage, in the context of historical buildings, usually constructed with natural stones, the decay phenomena of the materials can lead to dangerous detachments. Regrettably, one of those detachments already had fatal consequences, when in 2017 a Spanish tourist lost his life in the Santa Croce church. This is a tragic example of how important it can be to monitor and address deterioration patterns on stone materials when employed in historical monuments. To date, there is no monitoring plan to periodically check this kind of phenomenon. This research tries to provide a useful tool for organizing the data and a guide for identifying critical issues to report. To do that, we analyzed the degradation of stone materials used in historical buildings, and we built a data management tool to conduct a survey and organize a monitoring plan. In the historic center of Florence, in the past years, there have been several near-miss incidents involving detachments of stone corbels from balconies of historical palaces. You can here see 3 examples of such detachments that took place between 2018 and 2020. 2 of them happened in Via Cavour from Palazzo Pucci San Sedoni and one from Palazzo Ginori Conti, while the other happened at Palazzo Corsini in Via Il Prato. These collapses raise a safety concern as it appears that balcony corbels constructed from natural stone are especially susceptible to abrupt breakdowns. But why is that? Why do corbels from balconies fail in this way? If we take a look at what a corbel actually is, we can see that the stability issue is a combination of 2 main factors. Firstly, the corbels used until the early 1900s were constructed in a manner that employed them as a cantilever beam. That means that the corbel is subjected to a bending load, which generates a tensile stress within the granitic stone, a type of stress to which this stone is notably vulnerable. To compound the issue, these stones are exposed to various degrees of weathering, which further deteriorates their mechanical characteristics. Before the development of the monitoring application discussed in this work, we undertook extensive research on notable monuments and churches in the city center of Florence and its vicinity. This research involved the use of non-destructive techniques, both in situ and in the lab. For the on-field investigations, we used the ultrasonic pulse velocity test and the Schmidt-Hammer test, 2 techniques widely used to assess the mechanical properties of stone materials. In the lab, we performed physical and mineralogical analysis. These tests investigated the mechanical, the physical, the mineralogical, and the petrographic properties of the materials, offering a comprehensive understanding of the stone attributes. We studied about 300 corbels from structures in Florence, observing and understanding their degradation phenomena. By doing so, we were able to critically decide which indicators of degradation we should look out for in the surveying and in the monitoring phase. Our lab results showed that the corbels with the most noticeable degradation, including some detachments, had higher porosity and lower calcite content. These findings corresponded to a lower average ultrasonic pulse velocity and calorimetric rebound values. Low ultrasonic pulse velocity and rebound values generally indicates poor physical mechanical properties. We also used the AHC algorithm to check the consistency of the correlation between the observable degradation of the samples and their mechanical properties. We found out that the results of the non-destructive techniques could be aggregated in 3 main clusters. These 3 clusters corresponded to 3 different levels of surface degradation that we could observe. One of stones in good conservative conditions, one of heavily degraded samples, and an intermediate class. The connection between macroscopic degradation phenomena like fractures, erosion, and disintegration and poor mechanical characteristics is what formed the theoretical basis of our monitoring system. To effectively monitor each balcony as an individual sample, we needed to build a database that included both data management information and sample properties. Data management informations, such as the geolocalization, the number of corbels, or the photos of the sample and date of the survey, are essential to organize and console the database. The properties of each balcony, like the materials used for the corbels, the presence of a mortar layer covering the stone, or the forms and processes of degradation visible on the surface, are what we essentially need to monitor and study. To build this kind of database, we chose to develop a custom low-code system made of a mobile app and an integrated desktop report system. In this slide, we can see the first tool of the system, the mobile app. On the left, you can see the welcoming interface upon opening the app. From here, you can add a sample or search a previous entry. Creating a new entry triggers the automatic detection of geolocalization via the smartphone GPS, while also timestamping the hour and date of the survey. On the right, you can see the interface where you can compile the data for each sample. From here, you can use the toggles to input the specific characteristics of the balcony that we identified as relevant based on previous research. The data inserted from the operator is automatically saved, and the cloud-based nature of the app minimizes human error or data loss. The solution we developed was experimentally applied to survey the conservation status of balcony corbels in numerous buildings in the historic center of Florence. The area we selected for the survey is the UNESCO World Heritage Perimeter, indicated in purple on the map you have on the left. The streets highlighted in red have been fully covered by the survey campaign, meaning that all the buildings with corbels have been recorded in the system, while those marked in green are yet to be surveyed. In total, we were able to survey 256 buildings and 1,165 corbels, covering most of the busy streets in the center of Florence. These numbers make it clear how necessary it was to implement a digital system capable of organizing data efficiently. In this slide, we can see the second part of our system, the desktop report tool. From this interactive page, we can visualize the results of our survey and have a general view of the data. We can filter or aggregate the collected information using any parameter we like. For example, in the map on the left, we can highlight the critical situations in red and have an immediate numerical value of the sample visualized on the map. On the right, we can observe, using pie charts, the frequency and the distribution of the decay phenomena, both on the balcony slabs and on the corbels. This type of data management system really simplifies layered information visualization, and here we can see how, for example, it can allow a targeted focus on higher risk cases. In this view, we filtered the critical cases to provide a more immediate visualization of building locations compared to the general map. We can also view the total number of critical corbels and balconies. This filtering also made it possible to notice the differences in the degradation phenomena type and distribution compared to the generic case, as we can see from the pie charts on the right. In this final example, we can see the highest level of detail attainable, the one of the report of the single building. This sheet contains all the information on the conservation status of the corbels and the balconies at the singular sample level. In this stage, we can check the comments inserted by the operator and the photos taken during the on-site campaign. This allows for a quick evaluation of the single case and of its unique characteristics. The singular building report can automatically be extracted for every single case in just one click. This is a key feature of the system, as we needed to efficiently export a large amount of data. In conclusion, our research project addressed the critical need for preserving heritage materials while aiming to mitigate detachment risk and ensure public safety. Through extensive on-field research and data analysis, we have identified degradation patterns and established correlations between deterioration and mechanical properties. Once we had defined the objective of the survey phase, we developed a custom tool. The mobile app we specifically built facilitated an efficient data collection plan, allowing us to survey most of Florence city center. The report tool also proved to be an essential instrument for data visualization, making it possible to better organize and evaluate a monitoring plan. Finally, the ability to update the data and consult the database in the future makes these tools suitable for their use in periodic monitoring. This concludes my presentation. Thank you all for your attention, and if you have any questions, you can contact me on the mail provided. Thanks.